Okay, I want phones up. I don't want them out. I want you to pay attention. Headphones, of course, as always, need to be out of your ears. Both of them. Now, we are to not be working on anything but this. Grant, what are you doing?
Writing this,
What?
the thing, I'm still doing it.
How is that humanly possible?
Because I had to write down what we did yesterday.
No, you do what we're doing today. You do that on your own time.
No, I know, I just had to write down the, the questions and stuff.
Right now, look up here.
Okay.
You should have already had that written down. That's what we're supposed to be doing. Now, algebraic proof. It's an algebraic proof because basically we're going to solve an equation. What we're going to use is we're going to use what's called a two-column proof. And in a two-column proof, you have statements and reasons. There will be a given, which is given to be true, and then there will be a thing you prove, and this is how they have to be written down. What we're going to be given here is that 3x plus 4 is equal to 10. And what we're going to do is we're going to prove that x is equal to 2. You have to justify every single reason you do. Everything you do. Every statement you write, there has to be a justification for it. Once we get this written down, I want pencils down, and I want you to watch me do this proof. Once you get caught up to where we are right here. And then I'll say, okay, let's relax, everybody write this down. Make sure and draw your statement reasons. Okay. 99.9% of the time, or 99% of the time, whatever you want to say, you start with the given as your first step. Number 1, 3x plus 4 is equal to 10. Over here in the reason, you write the same number so it corresponds. What is the reasoning for that? Why do I know that's true? Well, because it was given to you. Easy enough, huh? Right? Now, here's where you guys are going to probably not like this, because you're going to want to write down the result. What would all of you do to solve this equation right now? No, okay. I want you to solve it like an algebra problem. I see what you're saying. You put 2 in for the x's. Yeah, you could do that. But what we're trying to do here, when we say algebraic, we're going to solve this like an equation. Okay? What would be the first thing you do to solve this equation? Okay, you would subtract 4 from both sides. So what I'm going to do is 3x plus 4 minus 4 is equal to 10 what? So what changed from here to here? I added a what? Do you see that that's what changed? Well, what property allowed me to do that? Well, if you look in the book, what property allows me to subtract the same number from both sides? What one looks like that? Can anybody tell me? I'll give you a hint. Look at the properties I had you write down. Excuse me. Do any of them look like you start with an equation and then you start with the same thing subtracted from both sides? You start with A equal to B, and then you go to what? Is equal to A minus C, or A minus C is equal to B minus C. Isn't that subtracting the same thing from both sides? So, what would your reason be here? Subtraction, property of equality. You can do it like that if you want. The book and I differ on this. But when you do simple computations, yes, this is substitution, but it's simple computations. What did I basically do here? Subtracted 4 from both sides. What do I need to do? I need to, when I get this, what did I basically do? Huh? I subtracted, right? But what is it called when I say, hey, is there an easier way to write 4 minus 4? It's 0, and what did I do? You guys remember? Just write simplify. The book is going to put substitution. I want you to put simplify. That's what you did. You simplified general simple computations, didn't you? Now, what's the next thing we're going to do here? But what am I going to do? And basically, I'm dividing both sides by what? You see how that's what we did? We divided both sides by 3. And if you look at the properties, as he is correct, doesn't this one right here say that you can divide both sides by the same number? So down here, you would write the what? What does this become? What does this become? How did I get from there to there? Simple computations, I? Did we start with what we were given? Did we justify every step to end up with what we're supposed to prove? You just wrote a 2-column algebraic proof. Is that hard? It's really not, is it? You just have to justify every step. Now, what we will do is we will add some algebra concepts to this. Everybody good now? Huh? Okay. Okay. We're gonna use all 2-column proofs here. First, you have to have a given and something you're proving. What do you think's the given here? In an if-then statement, which part is given? The what? If. What's the part you have to prove? The then. So it's given, and you're actually given two things, aren't you? That angle A is congruent to angle B. What else are you given? Measure of angle what? It's equal to, what are we supposed to prove? Probably saying, well, that's obvious. It is. I'm not going to argue with you there. Now, one thing you can do to make life a little easier on you is we can write both of these at once on as the given. But sometimes it kind of flows better. Well, first of all, it's given to us that angle A is congruent to angle B, right? That's given, right? Would everyone agree with that? Everyone stop writing and watch now. It's given to us that angle A is congruent to angle B. But it looks, you got to look at what you start with, and what do we want to end up with? The measure of angle B equaling 37. But I'm starting off with just what? Angle A, not the what? What's the difference between this angle B and this angle B? This is talking about the what? This one's just saying angle B. So it would help if I wrote this in terms of measurement, right? So the second thing I would write, and everyone look up here, is that the measure of angle A is equal to the measure of angle B. See how I've gone from congruency to equality? Stop writing, put your pencils down. This is important because now I can use substitution property, I can use all those equality properties, all that stuff, because I've changed from congruency to what? Equals. Now, what in the world is your reason for that? Well, didn't the definition of congruency say that their measures have to be equal? That they're the same size? So you know what you write? Definition of congruency. Okay? That's why that's true. Now, I still need to state now that the measure of angle A is what? Why is that true? It was given to us. Anybody see what do you guys think we could do next? We want to make that measure of angle A into a what? No, into a measure of angle B, don't we? Is there a way I could do that right now? Look at your properties. Is there a property that says you can do that? Nope. Substitution property says if A is equal to B, then A may be replaced by B in any equation or expression. So when I say, and everybody look up here, stop writing. When I say that the measure of angle A is equal to the measure of angle B, I'm saying that the measure of angle A is the same thing as what? So wherever I see the measure of angle A, what else could I put? So couldn't I put that right there? So I could say the measure of angle B is equal to 37. Is that what I'm trying to prove? Why was I able to do that? And am I done? Do you see how we proved it? We started with the information given, and we ended with what they wanted us to prove. Make sure to write that down. We're gonna do one more. Everybody got that down? We good? Okay, the next one we're gonna do. If CD is congruent to EF, then Y is equal to 8. And we have the picture. This is a little bit longer one. Here's the thing. When you write a given and prove it, even when they give you a picture, you need to write it. First thing that's given to you, I need to write this down in a statement. But the first thing given to me is that CD is congruent to what? EF. What else is given to me? By the picture. Isn't it given to me that the distance from C to D is what? Would you guys agree with that? What else is given to me? The distance from E to F is equal to what? What do they want me to prove? Do you guys, now everybody stop writing and look up here. Does everybody see how I got from this to that and that to that? Does everybody see that? Because that's what was given to you, correct? They're going to do the same thing with angles too sometimes. Put your pencils down. What's my given? My given's that. I'm going to go ahead and put that CD is equal to what? I'm not even going to write 2. And EF is equal to 15. You can combine more than one statement as long as they have the exact same what? Reason. Right? Result, reason, yeah. If the reason is the same, you can have more than one statement over here to kind of make it easier on you. Now, does anybody see where you're going to go here? To prove that y is equal to 8, what does this look like? What class does this look like? What have I told you guys? When it looks like what? Algebra, you probably need to create a what? Equation. What is your equation? Well, if these two are congruent, then this is equal to what? So that's your equation. But Here's the deal with proofs. All I've stated is this in terms of congruency. Before I can substitute, you can't skip steps. I have to say that CD is equal to EF. Why is that true? Definition of congruency. That's what says that if two segments are congruent, or two things are congruent, then they're the same size. Okay? So, now that I have done this, what can I do to make an equation now? See how I've stated that CD and EF, see I didn't have CD and EF anywhere in this proof but right here, did I? But now I've stated that CD is equal to EF, so what can I do? I can put 3y minus 9 in for CD, and I can put what? 15 in for that, and what was that? Wasn't that substitution right there? Because I replaced it, I substituted. After this, is it just an algebraic proof? What would your next step be? What would you do to solve this equation? Can you guys tell me? You would add 9 to both sides. What property allows me to do that? Addition property of equality. As a result, what are you left with? Equals what? I simplified. What are you going to do now to solve this equation? Both sides by? What allows me to do that? And my last step, what happens as a result? How did I get that? What did I tell you the book will put here? Substitution. Now, I'm going to give you tomorrow to work on this. I think I'm going to cancel doing 2-7 just yet. There we go. Here's another thing tomorrow.